Okay, so it's recording. Okay, so we're going to continue working on interval notation, but before I do that, let me mention a couple of things. So the first thing to mention is that I have posted my office hours now in the course homepage. So there will be Tuesday and Thursday from 3 to 4 p.m. Mountain Time. Now, if these hours don't work for you, I know they're probably not going to work for everyone, but don't worry about it. If you still want to meet with me, through a Zoom meeting, just email me and then we can set up a different time, outside of, 3 to 4 Tuesday and Thursday. I will also update the information for the CASM, so the Tutoring Center for Mathematics and Statistics. That's another good resource that you can use if you ever have questions on your homework or anything like that. In fact, I will create an extra credit assignment today, and I will post it in the assignments in Wild Courses, and you'll see all the information there. But basically for this assignment, I'm just going to have you go to the CASM, and if you have questions about, for example, the written homework that's already posted or any homework on my Open Math, you can ask them that. But if not, I'll ask you to simply ask them a couple questions, like get the tutor's name, get their major, and then, I don't know, maybe say something yourself. But I'll write down the details for that in the actual assignment. The only thing about the CASM and the other resources, such as STEP, is that you have to access it through a phone application or a web browser application called Penji. So we'll also post on the homepage the link to directly go to the Penji app to use the web browser version. But if you want to use your phone for this, so your phone to go to the CASM meeting, for example, then you can just download the app from either the Play Store or the App Store. It's available for both, so it works with Android and with Apple. So you can just look up Penji in either app. But for sure, I will put the link to the Penji app for the web browser version, so you can access that. And through there, it's very easy. You basically just make an account using your Uwayo email, and then you just choose what tutoring center you want. You'll get a list of those. So the CASM will be there. The STEP tutoring will be there. Just, for example, if you want to go to the CASM, choose on the CASM, and then you will see the list of available tutors. And you can just, right now it's by drop-in, right? So you can just say that you want to go to the session now, and then once the tutor accepts that, you will be sent to a Zoom session, kind of like this one, where you'll be one-on-one with that tutor. But I will post all of that information in the course homepage later today. I just wanted to let you know that that's coming. So any questions on that? Okay, good. So let's continue working on interval notation. So this is what we finished up talking about on Friday, as a lecture on Friday. I told you that in terms of interval notation, at least I like to think of interval notation as just drawing things on a number line. That's a good visual way for me to see what the intervals actually are. And so we did a couple of examples. So if we want to represent the interval including 0 all the way and all positive numbers greater than that, which was this first interval that I drew, in terms of a set written down in interval notation, it looks like this. So you want to include 0, so you use brackets, and then you want to go all the way to infinity, and then you use open parentheses for infinity, because I mentioned that infinity is not a number, it's just an object that represents a behavior, meaning that the number is getting larger and larger, right? So we can't actually include that number, so anytime you're using infinity, make sure to use parentheses. And then for the other example that we saw, which was this one, we're looking for all real numbers less than 1, right, and not including 1. Okay? So we drew the number line in terms of the set. Now you want to go all the way to the left, right, to negative infinity, right? So that's our left endpoint. And again, we use parentheses because we cannot include infinity. And then for the right endpoint, it's 1, right? But we're not including it, so we want to make sure to use parentheses there as well. Right? And basically, I summarized when to use parentheses and when to use brackets in this red box here. So those were the last examples that we saw on Friday. So now let's do a couple more. So example 3. Represent each set using interval notation. So let's start with the first set. So A, we're looking at the set of all x, such that x is less than or equal to, greater than or equal to -2, but also less than or equal to 2. So again, as I said, if it helps you, and it definitely helps me, I like to first draw a number line, just to see how it looks like visually. So let's plot this. So we want to include -2. So we're going to do a filled in dot there. We also want to include 2. So we're going to use a dot there. And here we know if we're including or if we're excluding because of this symbol here. If you have a symbol that has a less than symbol or a greater than symbol that has a line underneath, that means less than or equal to. So actually let me make a note of that here. So this means less than or equal to. And then if we have this means greater than or equal to. So in the case in which I don't have a line underneath, so kind of like this one here in the next example, that means that you don't want to include it. So that's how you know if you're including or excluding a given endpoint. Okay. So in this case, since we have the line underneath the symbol, then we're including them. So I draw the red dots. Then I want everything in between, right? Because I'm looking for everything greater than or equal to -2, but also less than 2. Okay. So on the number line, it would look like this. And then drawing it in interval notation, I want to include the endpoint -2, and that's my left endpoint. So I draw it like that. Then I want to include everything all the way up to 2, and then I'm including 2, so I close it with a bracket. And that's how you would write this set of all x, such that x is greater than or equal to -2 and less than or equal to 2. You would draw it in interval notation with this symbol here. So any questions on this first example? Okay, so now let's do the second one. So for B, we're looking for the set of all x such that x is less than or equal to -1 or x is greater than 1. So again, it helps me to draw a number line first. Okay, and then let's see what endpoints I have or what things I can just plot immediately. So I know I'm working with x less than or equal to -1. So I know I'm going to be including -1. So I'm going to draw a dot on -1. And then I'm also working with x equals 1, but I'm not including that, right? Because you don't see a line underneath the greater than symbol. Okay? So as I showed you in the previous video, the way you plot that is with an open circle. Now, what numbers are we working with? Well, we're looking for x greater than 1. So I'm going to plot that to the right. And again, you use an arrow just to point that you're taking all numbers greater than. And then we're also looking for all numbers less than or equal to -1. So now I do an arrow going the other way. So that's how it looks like in the real number line. Now let's write it down using interval notation. Now for this, it's going to be useful to remember how to use unions of sets. And the reason is because if you look at this number line, there's actually 2 intervals here. You have the interval going from -1 all the way to -infinity. And you also have the interval going from 1, not including it, all the way to +infinity. So you have 2 intervals here. So basically what we're going to do is we're going to write the first interval, and you always want to read the graph from left to right. So we're going to draw the interval for this set, the one that goes from -infinity to -1. And then we're going to union that. If you remember from the first videos that I posted, we had this union symbol. So we're going to union it with the interval that goes from 1 to +infinity. So if I do that here, so the first interval, we're going from -infinity. And again, I want to use parentheses because I cannot include any infinity in my interval, up to -1, including that endpoint. And then the other interval goes from 1, not including, up to infinity. Right? And again, I use parentheses. And then you do the union symbol in between. Right? And that's how you write an interval like this. When there's more than one interval in your problem, you need to make sure you write them separately and then combine them with this union symbol. Okay. So that would be set B, the set of all x such that x is less than or equal to -1 or x is greater than 1. So any questions on that one? Okay. Now the last one is basically a little bit of things that we've done in part A and B. So let's just go ahead and write it down. Again, I'm going to start with a number line so everything is more visual. So we're looking at the set of all x such that x is less than -3, not including -3, or x is between -3 and 3, again, not including -3 and not including 3, or x is greater than 3, not including 3. So we're not including any of the endpoints in this case because there's no horizontal line underneath the inequality symbol. So let's go ahead again, draw a number line. Okay, and again, I'm going to be working left to right, and you always want to be working left to right. Okay. So working left to right, I'm starting with this part here. So I have the interval of x less than -3. I don't want to include -3, so I draw an open circle, and then I'm moving towards the left. So I want all numbers less than -3. Now, the next one is the set of all x between -3 and 3. So x greater than -3 and x less than 3. Again, not including any of the endpoints. So I already have an open circle at -3, so that's good. So I'm just going to draw a line all the way up to 3. And then I don't want to include 3 as well, so I just draw an open circle at 3. And then finally, we have the set of all x greater than 3 as the last interval. And again, we're not including 3. So I already have an open circle at 3, so that's good. And then I just draw a line going to the right, meaning that I'm including all numbers x greater than 3. So that's how this looks like in the number line. And then writing this using intervals, how we do that? So you basically just do it, again, plotting each interval separately. So the first interval was going from -∞, so -3. Oops, so let's go ahead and do that. So -∞ to -3. And again, I'm not including any of the endpoints. And then union, what's the next interval? Always working left to right. So next interval is -3 to 3. And again, since we're not including any of the endpoints, we use parentheses. And then union, then what's the last interval is x greater than 3. And that looks like 3 to infinity. And then that's how you would write this set here, set C, using interval notation. So basically, the two things that are tricky are when to use parentheses, when to use brackets, and anytime you have separate intervals, like we do in parts B and C, so make sure that to write those intervals separately and then combine them using the union symbol. So are there any questions on these examples?
I have a question.
Mm-hmm.
So if we had one that was like -∞ to -3, but it included -3, and then we also had one that was like -3 to +∞, could you just write it as -∞ to infinity?
Yeah, that's a good question. Yeah, so what if we had something like this? So we had an interval that went from -∞ to -3, including -3, and then we had something like another interval that goes from -3 to infinity, right, not including -3. Well, if you were to plot this in the number line, so how would this look like? And this is why I like using the number line, because it makes me verify that what I'm doing is correct. Right, so if we did the first interval, it goes from -3, from -∞ to -3, including -3. So we're going to do a dot there. I'm going to do the arrow that goes towards the left. And then the other one goes from -3 to infinity, not including -3. Right? So we would kind of draw an open circle, but the fact that we have an open circle and a closed circle, basically, whenever you have a closed circle, you're including that number anyways. Okay? So even though I have a open circle for the next part, right? So the one that goes from -3 to infinity, I'm already including -3 on the first interval. Right? So when you draw the number line, you see that it looks like this. It's completely filled out. So the set in this case would be an interval notation, just the one that goes from negative infinity to infinity. Yeah, so definitely, if we have different intervals, you have to make sure, as long as one number is included in at least one of them, right? That's how the union works. If you remember the videos from the first videos that I sent, then you want to include it in your interval. So the fact that it's -3 is included here, even though it's not included here, it makes that we want to include it in the final interval. So any other questions?
Do you care if we draw the line a little bit above the number line?
No, I don't care. And with the lines, you only have to draw them if it helps you, right? So if you're comfortable not drawing them, you don't have to draw them at all. And then if you want to draw them, with the lines a little bit above the actual number line, then that's fine. Yeah, that's completely fine. Any other questions? Okay. So that should help you in terms of writing domains using interval notation, because I think that's how you write them down in MyOpenMath. So let's go to the next topic. Finding the domain and range of a function given its graph. Right? So we defined domain and range in the last couple of videos. We mostly have been focusing on domain because range is a little bit harder to find, especially if you're not given the graph. Okay? But if you're given the graph, it's very easy to find both the domain and the range. Right, so I just have 2 examples here, actually 3 examples. So we're just going to go over them, and we're going to write what the domain and range are for the given graphed functions. Okay, so starting with example 4. Find the domain and range of the graphed function. And if you look at this function, it's just a line. Okay. Now, it doesn't go the whole way, right? So you're going to work that out. We're going to work that out in terms of when we write the domain and the range, but it's part of a line. It's what you call a line segment. Okay. So how do you find the domain? Right? So finding the domain is, the way I like to think of it is working with vertical lines. So kind of like using the vertical line test, but we're not really doing that because this is given that's a function. We can say that it passes the vertical line test, but using vertical lines also helps you to determine what the domain is. So basically, let me draw, for example, a vertical line at x equals -1. You can see that that line crosses the graph of the function, right? The graph was actually drawn in green. Oh, and I drew that a little bit less than -1. So let's say it's negative, I don't know, 4/5, something like that. But anytime you draw a vertical line at an x value, if that vertical line crosses your graph, then you include that in the domain. So let me write that as a note here. So for domain, if you draw a vertical line, let's say x equals x naught, some x value, x naught. So if you draw a vertical line at x equals x naught, and this line crosses the graph, and again, the graph is the actual thing that is drawn, so what's drawn in green, then you include that in the domain. That's how I like to think of, finding the domain of a function when it's given graphically. And it's very nice because you can kind of draw the things yourself. And it's also, once you get used to it, it's pretty easy to see when will a vertical line cross the graph and when it won't. So for example, just by looking at the graph here, you can see that it doesn't matter where I draw my vertical line, as long as I'm between -2 and 2, that vertical line is always going to cross the graph. So for sure, I'm including in my domain anything that's between -2 and 2 in terms of the x values. Now in this case, I want to include -2, right? Because if I draw a line there, you can see that it also crosses the graph. And just like we used filled-in dots for intervals, if you want to include a number, we also use filled-in dots in terms of drawing a graph if you want to include that point. So here, this point here, let me draw it in green. So this point here that I did as a vertical dot, that's the point -2, -3. I want to include it in my graph, so I draw it as a filled-in circle. The same thing happens with the point 2, 3. I want to include it in my graph, so I draw it with a filled-in circle. Right? And then the same thing happens here. If I draw a vertical line at x equals 2, you can see that crosses the graph. Okay? So putting all of that together, if you write the domain of this function using set notation, interval notation, right, what would this be? So we know that anything between x equals -2 and x equals 2 is included. And then we also know that we include the endpoints. So in this case, the domain would be using brackets to include the endpoints, a set of all x that go from -2 to 2. And then you can see that anything outside that, so for example, if I draw a vertical line at an x value less than -2, it doesn't cross the graph. Okay, so you can see that very easily graphically. Okay, so that's the domain. Now, how do you do the range? Well, the range is exactly the same thing, but the only difference is now you're going to be working with horizontal lines. So let me do a note for that. So you do the same for the domain, for the range. But using horizontal lines. Say y equals y naught. And we'll go over how these things look, but basically, if you're given a graph and the graph is just x equals 3, that basically looks like a vertical line at x equals 3. If you're given a graph and that graph is y equals 4, that's basically a horizontal line going through y equals 4. So for x values, look at vertical lines. For y values, look at horizontal lines. But it's basically the same thing. So for example, if I want to check if the y value, y equals 1, is in the range, I draw a horizontal line. Oops, I wanted to use purple, sorry. So I draw a horizontal line going through y equals 1. You see that that crosses the graph, right? So y equals 1 is in the range. Okay. And you can do that for other values. Let's say I want to see if y equals -2 is included in the range. So I draw a horizontal line that goes through y equals -2. And you see that that line crosses the graph. So I'm including y equals -2 in my range. So once you know that, if you look at the graph, you can see that doesn't matter what horizontal line you draw, as long as it's between -3 and 3, that horizontal line is always going to cross your graph. So for sure, we know that our range is between -3 and 3. Then the question is, do we include the endpoints? Now, again, since I included the points -2, -3, and 2, 3, because I use dots. So for example, if I draw a horizontal line at y equals 3, you can see that it crosses the dot. Right? So I'm including that y value in the range. Same for y equals -3. I draw a horizontal line. You can see that it crosses the graph. So I'm including that. So then for the range of this function, putting everything together, we know we're including everything between -3 and 3 in terms of y values. And then we're also including -3 and 3. Okay, so this would be the interval, -3, 3, with brackets, right? Because we're including those. And that's basically how you want to think of this if you're given a graph, right? Think of, for x values for the domain, think of vertical lines. And for the range, the y values, think of horizontal lines. Okay. So any question on this example? And we'll do more. We'll do 2 more. But any questions on this one? Okay, so this was a sort of simple one. So let's look at one that's just a little bit, just slightly more complicated. So find the domain and range of the graphed function. Okay. Now here, I already used something that's different. So if you see, I have the point pi over 2, 1, but I'm not including that. And you know that I'm not including it because at that point, I use an open circle, right, instead of a filled-in circle. The only other point that I labeled was the point -pi over 2, -1. I do want to include that one, so I drew it with a filled-in circle. Okay. So let's find the domain first. And again, for domain, just think of vertical lines. Okay. So anytime you draw a vertical line through an x value, if it crosses the graph, then you want to include that x value in your domain. So I wanted to use red here, not purple. Okay. So just looking at this graph here, as long as I draw a vertical line for x values between -pi over 2 and pi over 2, you can see that any vertical line that I draw is going to cross the graph. Okay. So for sure, we want to include all x values between -pi over 2 and pi over 2. So once we know that, now we focus on the endpoints. Okay. Do I want to include x equals negative pi over 2? Okay, so what do you think? Right, so do I include x equals, do I include x equals negative pi over 2 in the domain? And I heard yes. Good. Yeah. So we do want to include it because it's filled out as a filled-in circle. So if you draw a vertical line going through there, we see that it does cross the graph. Now, do I want to include x equals pi over 2 in the domain?
No.
Perfect. Yeah. I don't want to include it because if I draw a vertical line, you see that it doesn't cross the graph because I have an open circle there. So putting all of that together, what's the domain of this function? Well, we know we want to include everything between negative pi over 2 and pi over 2. We also saw that we want to include negative pi over 2, but we don't want to include pi over 2. So draw that with a parentheses. Okay. Now, same thing for the range. Just think of horizontal lines instead of vertical lines. So if you look at horizontal lines, it doesn't matter where I draw a horizontal line, as long as it's between negative 1 and 1, right? If I draw a horizontal line going through a y value between negative 1 and 1, it's always going to cross the graph. So we definitely want to include all y values in the range, right? All y values between negative 1 and 1. Now we ask, okay, what about the endpoints? What about y equals negative 1 and y equals 1? So I start with y equals negative 1. Do we want to include that one in the range?
Yes.
Yes, perfect. We do want to include it in the range because if you draw a horizontal line, and I drew it a little bit lower, but if you draw a horizontal line through y equals negative 1, you see that it crosses the graph. And it does because we're including the point that includes y equals negative 1, right? We're including the point negative pi over 2 comma negative 1. Okay. So yes, we want to include y equals negative 1. What about y equals 1?
No.
Yeah, perfect. We don't want to include it. And again, you can think of it two ways. You can draw a horizontal line. You see that it doesn't cross the graph because we have an open circle there. And then if you want to think of it as just points, we're not including the point pi over 2 comma 1. So in particular, we're not including that y value. Perfect. Right, so then putting all of that together, the range of this function is going to be everything between negative 1 and 1. We want to include negative 1, so we use brackets. And then we don't want to include 1, so we use parentheses. Okay, good. Okay. Now, the last one. Find the domain and range of the graphed function. And so this one's definitely a little bit more complicated, but hopefully, just using the method that we discussed in the two examples we saw before, we should be able to do this. So let's start with the domain. So let's start with vertical lines. Okay. So if I draw a vertical line, for example, at x equals negative 2, I'm crossing the graph, so I definitely want to include that. And the same happens if I move to the left of negative 2, right, until I reach negative 3. And I do include negative 3 because there's a closed or filled-in circle at that input. Okay. Now, if I move to the right of negative 2, then again, if I draw vertical lines, I'm including those because they cross the graph. But once I reach x equals 1, since there's an open circle there, you see that that vertical line does not cross the graph. So using that information, the first part of our domain, again, always working left to right, the first part of our domain would be the interval, including negative 3, but excluding negative 1, right? Because there's an open dot there, or because if you draw a vertical line, it doesn't cross the graph. Okay. Now, for anything between negative 1 and 1, are we including that in the domain? Any ideas?
No.
No.
Yeah, perfect. No, so anything between negative 1 and 1, not including the endpoints for now, we don't want to include it in the domain. And you can see why. Right? Say I draw a vertical line here between negative 1 and 1, you see that it doesn't cross the graph at all. Right? And same for any vertical line that I draw between negative 1 and 1, not including the endpoints. It's never going to cross the graph because there's no graph there. Yeah, so for sure we don't want to include anything between negative 1 and 1. Now, what about the endpoints? We already saw that we're not including x equals -1. What about x equals 1? Are we including that?
Yes.
Yes, we're including it, right? Because you can draw a vertical line, you can see that it crosses the graph, or simply because you know that we're including the point 1, 1/2, right? Because I drew it as a filled-in circle, so we know that x equals 1 is in the domain. Okay, now what about x values greater than 1? What are we including?
We go up to 3, but not including 3.
Yeah, perfect. Yeah, so now looking at x values greater than 1, if you notice, if I draw a vertical line, it's going to cross the graph until I reach x equals 3. At x equals 3, since there's an open circle, the vertical lines don't cross the graph, right? So we don't want to include x equals 3. Or another way to think of it is, okay, there's an open circle. That means I'm not including the point 3, 2. So x equals 3 is not in the domain. So putting all of this together, we're going from -3 to -1, including -3. Then we skip everything in between. Right? So we do a union with the other interval. And the other interval we saw is 1 included all the way to 3, not including 3. So any questions on the domain part? Okay, now the range. The range, I think, might be a little bit more complicated, but hopefully we can do it. So for x values, we work left to right. For y values, we work down up, right? Because we always want to work from largest negative numbers to largest positive numbers, right? So in terms of the y-axis, since it's the vertical axis, the large negative numbers are on the bottom, the large positive numbers are on the top. So you want to read your graph as going from bottom to top in terms of the y-axis. Okay, so I should have said that in the previous example. But okay, in this case, if we're moving from -infinity, let's say up to 0, what y values between -infinity and 0 would I include in the range?
Only -1, that's the only point.
Yeah, so I look at what y values are included in the graph on the interval -infinity to 0, right? So if you notice here, the only vertical line that you can draw that's actually going to cross the graph is the one that goes through y equals -1. Any other line that you draw, horizontal line, because working with y values, is not going to cross the graph between -infinity and 0. Okay. So correct. We want to include only y equals -1, at least for this part. Okay. Now, working from 0 to positive infinity, what y values do I want to include? And let me make something clear here that this top portion is 3, y equals 3. So on the interval 0 to infinity, what y values do I want to include in the range?
-1.
On the interval 0 to infinity.
Oh, 1 to 3.
Okay, 1 to 3. Okay, but I'm not including 3 here in this point, 3, 2. I have an open circle. Do I still include 3 in the range?
Yeah, because the graph goes up there.
Yeah, and then I heard someone else also mention something. What was the other thing the other person mentioned?
Yeah, because the line hits it. So
Yeah, perfect. Perfect, yeah. If you want to think of it in terms of horizontal lines, why do we include y equals 2? Right? So like I said, here I have an open circle, right? And that goes through the point 3, 2. So you could think, well, I'm not including y equals 2 there, so I don't want to include it in the range. However, if you draw a horizontal line through y equals 2, even though it doesn't cross at this point 3, 2, it does cross at this point here. So again, this is why I think it's very useful to think of horizontal lines. So yes, even though we're not including the point 3, 2, we do include y equals 2 because the horizontal line going through that y value does cross the graph. Okay. Now, so that's the tricky part. So in terms of the other y values, anything between 1/2 and 3, I'm going to include, and you can see by drawing horizontal lines that that's the case. And then I want to include 3, right, because that's shaded in the graph. And I do want to include 1/2 because I drew that as a closed circle. Okay. So in terms of, on this interval, then the range would be So we're gonna have a union here, but on this interval, it would be y equals 1/2, including, 2y equals 3. And then 3 we're including as well. Now, how do I include y equals -1? Because we know that that was also part of the range. Now, for an interval, you always want to have an endpoint and a starting point and an endpoint. However, it's just a point. So if I only have a point, how would I write it here? Any ideas?
But I have a question.
Yeah, go ahead.
The point 3, 2,
Mhm.
isn't 2 the highest it goes to? Why is it 3? Isn't 3 the x?
Yeah, okay. Yeah, so in terms, so remember for range, you're looking at horizontal lines. So if you draw a horizontal line at y equals 3, you can see that it does cross the graph, right? So what's tricky here is that the graph is kind of curving down, right? So in this case, the point that I drew, the point 3, 2 is not actually corresponding to the highest y value, because you can go above, y equals 2, draw a line, and you can see that it's still crossing the graph, right? So we're definitely including values y greater than 2 in the range. And we go all the way up to y equals 3.
Thank you.
Any other questions on why do I go all the way from 1/2 to 3?
Can't you just like think of it as another ordered pair at 2, 3 with the filled in dot? Like around 2, 3 where the graph is at its peak, there's like another ordered pair.
Yeah, exactly. Yeah, exactly. Definitely. Yeah, there's definitely another order pair here, right? I didn't write it explicitly, but there's some order pair there. It seems like it's a little bit bigger than 2. So let me just write, it's some x input, and the y value is 3. Yeah, so definitely, even though I didn't write, the order pair explicitly, you know that the order pair is there because it's in the graph, right? Yeah, so that's another way you can think of it. That's a good point. Any other questions specifically on why I'm including the whole interval 1/2 to 3? Yeah, it's a little bit tricky. Okay, now with including just a single y value, y equals -1 that we got before, for intervals, like I mentioned, you want to have a distinct starting point and a distinct endpoint. So if in your interval notation, you're in a case where you only have one specific y value, like y equals -1, what you do is that you just write it in set notation. So you would write this, the set including -1, union the interval 1/2 to 3. And again, y equals -1 came from this vertical line here. So any questions on why on this particular example? And basically, if you can do this one, I think you should be able to do all of the ones in the homework. So it's kind of like the most complicated one that you would get. Okay, if you need to go back to it, it's going to be in the notes that I post. And since I'm recording, you can also go back and hear what I'm saying and what the other students that are participating are saying in the recording. So moving on to the next topic, we want to be able to graph constant and linear polynomials. Now, I won't define what a polynomial is yet. Right? I'm just going to tell you what it is in this particular case. But for now, we're going to start with constants. Right? So I kind of already told you how to graph horizontal lines and vertical lines. But basically, in terms of graphs of constants, there are two types. If you have a function that's just given by x equals x naught, then that's a vertical line going through x naught, right? X equals x naught. If you have a graph that's just given by y equals y naught, right, then that's just a vertical line going through, a horizontal line, going through y equals y naught. Right? So it's as simple as that. So let's just do one example. Graph the functions x equals 2 and y equals -1. I'm going to graph them in the same xy plane. So first, we want to graph x equals 2. So as we saw, if you have a function given by x equals 2, that's just a vertical line going through x equals 2. So x equals 2 is around here. And draw a vertical line. Now, make sure that you draw a solid line. So in the previous examples, I was drawing vertical lines because I'm not actually drawing those as part of the graph, right? I'm just drawing lines so that I can tell what is in the domain and what is the range. But if you're actually graphing, you want to make sure to always draw a solid line. So here we want a solid vertical line going through x equals 2. And I see that I drew this backwards. It should be x is always the horizontal axis, y is the vertical axis. Let me make sure that that passes through there. All right, perfect. Okay, so that's the graph of x equals 2, right? Just the vertical line going through x equals 2. Now for y equals -1, then that's just a horizontal line going through y equals -1. So y equals -1 is somewhere here. Then just draw a solid horizontal line going through there. And that's it. So graphing constant functions is very easy. If it's given by x equals something, it's a vertical line. If it's given by y equals something, it's a horizontal line. So any questions on that?
Why do we not draw arrows?
Oh, yeah, definitely. Yeah, since it's a whole line and I want to make sure that it's going the whole way, yeah, definitely you can draw arrows here. If you didn't draw arrows in the homework, I mean, you just draw those lines, I would understand that that you're saying that that's the whole line. Usually, if you want to draw a segment, right, so if I wanted to say that this is not the whole line, just a part of it, let's say the line x equals 2, if I wanted to just draw a part of it, I would make sure to include dots, and that would make sure, okay, that's just a segment, just a part of a line. So in general, if you just draw a line without endpoints, I would understand that you're drawing the whole line, or you can also draw arrows to make it explicit that the line is going to infinity up and to infinity down in this case. Yeah, good point. Any other questions on this or comments? Okay, good. Now, graphs of linear polynomials. So again, we won't define polynomials in the most general form, but as of now, a function of the form f of x equals a constant times x plus a constant b, where a and b are real numbers, that's called a linear polynomial. Okay, so anything of the form ax plus b, that's a linear polynomial. Now, there are a couple things that we can note just given a function of the form ax plus b in terms of the graph. Right? So first of all, the graph of a function like this, so the graph of a linear polynomial is always a line. Now, that's why it's called a linear polynomial. Right? So it's always going to be a straight line when you graph it. And then you can read off some information of the line just from the function. Right? So first thing you can read off about the line is its slope. Whatever is multiplying the x value, in this case a, that's going to be the slope. And we usually call the slope with the variable m. Right, so this particular line has slope m equals a. Another thing you can read off just from the function is, where does the line cross the y-axis? And it crosses the y-axis at the point 0, b. And that's the third point that I drew there, that I wrote there. Right? So you can get a lot of information from the line just by looking at the function. Right? You know the slope and you know where it crosses the y-axis. And the nice thing about plotting lines is, since you know it's a straight line, all you need are 2 points. Right? Graph any 2 points on the line, and then just join them with the line, and you know that that's the precise function. Right? That's a precise graph. So that's basically what we're going to do. So example 8. Graph the function y equals 2x minus 1.
I don't go ahead in class anymore, because I learned this last
Sorry?
week Wednesday from the homework.
Sorry?
It's required.
Does anyone have a comment? I think I heard something.
I'm going to keep going ahead. I'm already on 1.4, and that's due next week.
Okay. So for graphing the function, right? So what do we want to do? Right? So we know it's a line. Right? And you can see it just from the definition here. Right? It has the form ax plus b. Right? So in this case, our a is 2, and our b is -1. Right? So you definitely want to make sure that you include the negative sign in that. Right? So as I mentioned, in terms of graphing a line, it's very easy. All you need to do is plot 2 different points and join them with a line. And 1 point we know immediately. So we do, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right. So 1 point you always know immediately, right? We always know, given the function, where does the line cross the y-axis? Right. So in this case, at what point does our line cross the y-axis?
-1.
Yeah, at the point 0, -1. And again, we know that because b is -1. Right? So just from what I gave you before, whatever your b is, you know that your function or your line is going to cross the y-axis at the point 0, whatever b is. So in this case, 0, -1. And then how do we find another point? Well, you can just use the slope. So the way you want to read the slope is, if it's positive slope like 2, and I always do something like this, right? I always like to draw, if it's not a fraction, right, like in this case, I always like to draw a 1 underneath. The reason why is because you want to read slope as rise over run, where rise means change in the y-axis, so vertical motion, and then run means change in the x-axis, so horizontal motion. And then you always want to read rise first, so numerator first, and then run. Right? So here, this is why I say that it's useful to, if you're not given a fraction immediately, to think of it as just a whole number divided by 1. So what that is telling us is that the rise is 2, so we want to move 2 units up, and then the run is 1. So we want to move 1 unit towards the right. Okay. So if I do that here, so I'm at 0, -1. I know that the slope is 2 over 1. So I want to move 2 units up and then 1 unit to the right. And that takes me to the point 1, 1. And then once you have 2 points on your graph, you can just combine them with the line, and then that's your graph. Yeah. And that's basically how you would want to do this all of the time. Just plot the where the point where the graph crosses the y-axis, and then use the slope to find another point. So let's do another example. Graph the function y equals -3/2 x plus 1. And again, here we're given some information already. A is -3/2, and sorry, A or M, yeah, A or M is -3/2, and B is +1. Okay, so again, if you want to graph this, just draw the xy plane. And draw the xy plane. Plot the first point, which is, again, the easiest one to plot is where it crosses the y-axis. Now, since we know that b equals 1, we know that we're crossing the y-axis at the point 0, 1. Right, so x equals 0, y equals 1 is this point here. Now we read the slope. And again, you want to read this as rise over run. Right? And anytime you have a negative in front, always read the negative as part of the rise. Okay? So in terms of run, you're always going to be moving towards the right. In terms of rise, if it's positive, you're moving up. If it's negative, you're moving down. Okay? So in this case, the rise is -3. So I'm actually going to be moving 3 units down. And then the run is 2. So then I'm going to move 2 units towards the right. Okay? So if I do that here, starting at 0, 1, and using the slope, the rise is -3. So I move 3 units down, and then the run is 2. So I move 2 units towards the right, and I end up at the point x equals 2, y equals -2. So x equals 2, y equals -2. Now, again, once you have 2 points, then all you have to do afterwards is just connect those 2 points with a straight line. And then that's the graph of the line. Okay? And that's basically how you're going to be graphing linear functions, right? Just find, And you don't have to start with the y-intercept where it crosses the y-axis as the starting point. It's just the easiest one to read off, right? Because you're always given the y-coordinate of that y where it crosses the y-axis as you're given your b. Okay? But you can start anywhere else. Right? Okay. So with these examples, you should be able to do most of the homework. The only thing that's left is defining piecewise functions, but so I'll put that in the video that I'm going to record for tomorrow. But even if I haven't done it yet in class, I think you might be able to figure it out on your own. So definitely you can try some of those piecewise function problems. If not, just wait for me to upload the video, sometime later today, and then watch that, and you should be able to complete homework 2, which I believe is due tomorrow at midnight. Okay, so that's it for the lecture. So if you want to go, you can go. If you have any questions, I'll stay for a couple minutes.
I just have one question for that homework that's due September 1st. That's written. What app do we have to download that just scans it and uploads it to our Canvas?
Yeah, so if you don't have to actually download the file. You can just write down everything on a separate white piece of paper. So if you go to the syllabus under written homework, I have the specific instructions, but basically on a separate piece of white plain paper, you can just write down the problem, write down your solution, make sure that everything's legible, organized. If you're using pen, make sure that there are no scribbles. And then once you've done that, the way you want to submit it is scan it either with a actual scanner or with a scanner app. So in the course homepage, there's a link that sends you to some free scanner apps for your phone. So make sure to scan it. And then once you scanned it, that's what you want to submit to the homework assignment in WIO course. It's just the scan of your homework.
Got it.
Can you go up to the definition of linear polynomial real quick?
Yeah. Yeah, definition 5. Is there anything confusing about the definition?
No, I just didn't catch it.
Oh, okay, yeah. Any other questions?
Thank you.
Yep, no problem. Okay, so if there aren't any other questions, I'm going to go ahead and stop the recording here. So I'm going to give you one last chance. Any questions? Okay, so I'm going to stop the recording. I will post all of the information that I said I was going to post at the start. I'll do that right now. And if you have any